the data science process. I think that if you were to ask a data science or ask 5 different data scientists what they do at 5 different places, it can all be very, very different. That's because out in the world, data scientists, I think, usually work on either a part or have some overlap between data science and something else. So that's actually very, very common. But there are a couple people who have come up with more definitive, I guess, definitions. So this is one of them, the OSEMN data science process. And the data science process basically encompasses the gathering of data. It encompasses the cleaning of data, because data out there, if anyone has ever done any sort of like data entry or like scouring of like survey responses or spreadsheets, you know that data is not always consistent and clean. So data scientists actually do that as well. There's an explore step, which you're just taking a look to see what your data is telling you on an overall like general sense. And then data science also includes modeling, and modeling is where we get into the machine learning aspect. And then we interpret, and then use your interpretation to maybe help drive company decisions or help drive actionable insights, things like that. So we're going to go through a very, very simplified version of this process in creating a movie recommendation system. So we're going to use a bunch of different things here. SVD, that complicated algorithm that we just talked about, is actually built into this library. It's built into this library called Surprise, which kind of stands for Simple Python Recommendation System Engine. So we're going to code out a recommendation system using Surprise Library's SVD algorithm. We'll see how simple it is using code. All right, so first we're going to import all the things we're going to use. We're going to be working with some NumPy, pandas, matplotlib. This basically allows us to work with data in a spreadsheet and make some graphs out of it just so we can explore. And then here you can see we have our Surprise. Surprise is the library that houses that SVD algorithm we were talking about earlier. Okay, so first let's grab our data, right? First step is obtain, let's grab our data. Manage to find a ratings data set somewhere on the internet. You can feel free to check it out and get some information on that. When I run this code, this is what our data looks like. We have a bunch of user IDs, and this tells you that we actually have 100,000 rows, 4 columns. So we have user IDs, movie IDs, ratings. Actually, if you go to this data set, you can figure out what each movie ID refers to. But for now, let's just assume we don't have that. And then you can see what user 1 rated movie 31, what user 1 rated each of these movies. And you can see that there's some variance there. And there's also a timestamp, which some recommendation systems actually take into account when they rated something. We're not going to do that for now. Okay, so let's just take a look at the ratings that we have. This next step of scrubbing and exploration, there's not too much to clean here. Let's just assume that this is fairly clean. If not, you would actually go through some step of cleaning your data, removing like inconsistencies. Maybe in this data set, it's messy. Even though movies here are rated 1 through 5, maybe you have a couple like -5s or something like that. You want to clean those out. But we don't have to do that now. So next, we're going to do the explore step. Finding significant patterns and trends using statistical methods. We're not going to go into any stats today. I feel like we've already talked about a lot. But very, very simply, let's just take a look at what our data is looking like. So this basically shows us a value counts of our ratings. Actually, let me show it to you in graphical form. This is basically what our data looks like. Number of ratings and the actual rating itself. So what this is saying is that 4 is the most common rating. In this file, we happen to have 0.5 values as well. And so roughly about 15,000 people rated 5s, roughly almost 30,000 people rated 4. So this is just a very, very brief exploration of our data. So based on this, we do expect a lot of our predictions to average out between 3 and 5. Just for the sake of it, we can do a little bit more graphing just to see. So these are just a couple other graphs. Number of reviews per user. There are some users that apparently have rated close to 2,000 movies, but most of them you can see sort of hover around like the 100, 200 range. Another one we can see, review frequency per user. Most users have, let's see, around 1 to 2 reviews. You can do the same thing on the movies end. And you can see that there's 9,000 movies in this data set, and the average number of reviews per movie is 11. And you can do as much exploration as you want on this data set. but we're going to get straight into the modeling portion. Okay, so there's some lines of code here. If you're not familiar with this, don't worry at all. I'll tell you all what each line is doing. There is some documentation on how this library works. I've linked it over here, but all we need to do is we're going to use this table of, actually, let me just print it out here. We're going to use this table of information. So we're going to use this data. We're going to use the user ID, the movie ID, and the rating. It's not exactly in the format of the utility matrix that we had, you know, with like all the movies on one end and all the users on one other end. That's because if you're storing like all of these, 9,000 movies, is that what I said earlier? 9,000 movies, and how many users have we got? 600 users. It's going to be a pretty big matrix. It's actually more efficient to store your info like this, but within the algorithm, they're going to create the utility matrix for you. So all you have to do is just feed it in the data in this format. So that's what we're doing here. We're telling it what our data is in this line. We're going to give it a reader object. And this reader object just teaches it how to interpret these specific numbers. And then we're going to load in our data set as well. And with that, that is how we take this data and have Surprise understand what our data is. Next, we're doing a train test split. Earlier, we had a question about like that back testing and how we can figure out, like, take some of the ratings that we already have and then see how well our model predicts. We'll talk about that in a little bit. But we're going to take all of our ratings and we're going to do what's called a train test split. So usually what you do in machine learning to make sure that your model is working well and not and honestly, not pigeonholing. I think someone had a question about pigeonholing. To make sure that it's not pigeonholing to that specific group of data, you do what's called a train test split. So you just assume that 20% of your data, and you see how this is test size 0.2, you're assuming that 20% of your data, you're going to assume that you just don't have it. And then you're trying to make predictions on that 20% to see how close the predictions are to your actual values. And that's what the train test split allows for. So you're only going to train your model. You're only going to show your model 80% of the stuff and then say, okay, if you've learned 80% of the stuff, based on the 80% that you know, how well can you guess on the other 20%? So that's why we're doing a train test split. All right. So you'll actually see training the model is literally just these like 3 lines over here. It's pretty incredible. So first, what you do is you're going to create a model. And within this library, it already has SVD for you. So this is how you create an empty model. And then what you do here is you take that model that we call SVD in lowercase, we fit it to our train set. So we're going to give it that 80% of data, and it's going to do all of the math that we talked about earlier. It's going to do that, like set 1 to X, figure out what the best value is over and over again. So when I run this, you see how it takes a little while to execute, like 1, 2, 3, yeah, about 5 seconds to execute because it's doing all of that math on that data set. The model has been trained. And at this point, we can actually take a look at our test set. Let's run this, and I'll talk a little bit more about what's going to happen here. So cool. This prints out our RMSE, and this RMSE actually stands for, on our test set, those 20% of values that we had, the model did not see, but when we made a prediction on the test set using the information about the 80% that the model knew, on average, it was 0.89 stars off. So 0.9 stars off, which I think is pretty good, especially for the fact that we only trained this for not like 5 seconds. So let's take a look and see what we have here. This is us testing the model, but let's take a look at these predictions. Hopefully these are not the worst. So let me make this a little wider so it's all in one line. Okay. So in our randomized test set, so when you do the train test, it's important that it's random. We're going to see here that for user number 547, item number 72169, the real rating was 3 and the estimate was 2.75. So for that specific movie, it was only 0.25 stars off. That's pretty good. In other cases, they might not be as good. Let's see, for example, over here, the real rating was a 1, but it estimated a 2.71. So that's like a good 1.7 stars off. So it does fluctuate a little bit depending on, you know, maybe For the ones with fewer error, with a lower amount of error, maybe that user just has more information there. Hard to say, especially when these, this like gradient descent process is going over and over again. It does become a little bit opaque. But yeah, it does fluctuate at times, but overall, on average, about 0.9 stars off. And just like that, and like, I think when we got to the code, it wasn't even like 5 minutes. We have a recommendation engine. So really quickly, we can test it and we can assume that we know like the users and the items. So let's say you know that you're user number 5. You can actually use a predict function to figure out what you would rate movie number 100. So you can pretty much plug in any number for user to be from 1 to 671. You can plug in any item number from 1 to 9066. And for any user item combination, you come up with a prediction, which is pretty neat. So here, user 5 item 100, your estimated rating is 3.624. Unfortunately, we don't have who this user is or what this movie is, but you can pretty much do this for any number here. So as long as it's under 671, maybe we can do, I don't know, 345. Here we can do something like that. And you have another prediction. So you can imagine when you have all of this data stored, you can just sort your movies and recommend the best ones.